Good morning, everyone. Warm welcome to Multiculturalism and Migration Observatory seminar, which today will be devoted to the theme of big data in migration studies. My name is Konrad Pędziwiatr, and together with my colleague Dobrosława Wiktor Mach, we will lead this seminar. The event is scheduled for up to 2 hours and will include a short introduction, talks from distinguished guests, and a Q&A session. Before we start, let me very briefly talk you through the housekeeping. The event is being recorded and we'll try to share it on our YouTube channel. Your microphone is muted and your video turned down to avoid disruptions. For the Q&A, we will invite you to unmute yourself and turn on your video to ask questions directly if you wish so. You can also ask questions in the chat box anytime during the seminar. Please note that the video, sound, and chat messages are saved as part of live recording. So if you do not wish to appear in the recording, please use private chat to ask questions. Today, Multiculturalism and Migration Observatory seminar will try to answer the question how the use of data innovation can complement traditional migration data sources and fill existing information gaps. Big data, including anonymized data generated by users of mobile devices, internet-based platforms, or by digital sensors and meters, present an enormous opportunity to complement traditional sources of migration data and improve knowledge of various aspects of migration. The potential of these innovative sources, however, comes with significant challenges. Some of the most important ones are confidentiality and ethical issues in using data automatically generated by individuals, often without their informed consent, as well as civil liberties concerns due to the risks of using such data for surveillance purposes, which are particularly serious in the context of irregular migration and forced displacement. Another challenge has to do with the fact that users of social media or mobile phones are not necessarily representative of the population at large. Thus, one needs to remember about the limitations of research findings. Finally, there are numerous technical, analytical, and legal challenges. Some of these challenges are due to difficulties in accessing data held by private or state actors or using data for research purposes. In spite of this and other challenges, the big data represent a new and promising source of knowledge about migration processes. Last year, the observatory team used this type of data to better examine the stock and neighborhood concentration of Ukrainian migrants in the city of Krakow. We want to learn about the potential of these innovative sources, and hence the theme of today's seminar with distinguished scholars, Tuba Bircan and Carlos Arcillon Calderon, who use big data in migration studies on an almost daily basis. I'll now introduce our first speaker, who will speak for up to 30 minutes, and then my colleague Dobrosława Wiktor Mach will introduce second speaker, who will speak for the same amount of time for presentation, and then we will have a Q&A session. So let me introduce the first speaker. Tuba Bircan is a professor of sociology at the Department of Sociology and a research coordinator at the Interface Demography at the Vrije Universiteit Brussel, VUB. She holds a BSc and MSc in statistics and a PhD in social and political science. Her research interests include migration, diversity, refugees, equal opportunities, social research, perception, evidence-based policymaking, mixed methods, data-driven analysis techniques, big data and machine learning applications for social research, and how to study hard-to-reach groups. She is the scientific coordinator of Horizon 2020 project Hummingbird, enhanced migration measures for a multidimensional perspective. She has published mainly on the methodological aspects of migration studies, inclusive policies, and inequalities. Tuba, the floor is yours. And thanks once again for accepting the invitation to be our speaker today.
Yeah, I think you can see my screen, right?
Yes.
Okay, great. Thanks a lot for the invitation. So I'm pretty honored, to be honest, not only because it's my first time to talk to a mainly Polish audience, but also the overall audience of the observatory, because I am working very interdisciplinary, but also multi-stakeholder approach. So for me, it's very valuable to have people with different backgrounds. So I would like to say that today's presentation is not extremely technical, so I will try to give you the insight about what has been done with big data for migration statistics in general, or migration measures, and we will go through on several studies. I will also discuss our project, and then if you do have specifically technical questions, we can also discuss them during the Q&A. But today I will try to give you the insight about what can we do with big data and what are the obstacles that we need to overcome when we are applying that. So my presentation will be mainly focused on migration measures, so how we can use big data to improve or to complement the migration statistics. And my colleague Carlos will talk about the integration aspect. So I will not touch that part in my presentation. So for the people who are working on migration, and when we refer to migration statistics, in fact, we're talking about different data sources. So in general, the traditional data sources include population censuses. So in former times, it was really like census applications, and then it became more like population registers. Then we can use these to measure migration flows, like incoming, outgoing migration, and then the stocks, like presence of people with migrant background or with different ethnicities. And then we do use administrative sources. As I said, we can use the population register, but there is also like social security databases we can use, or sometimes visas. And then we also work with large-scale surveys. So it depends on the level, because we do have European level surveys like EU-SILC and LFS, which are more than a survey, and they are kind of policy frameworks, or general health survey. We also have specific surveys by the countries, or sometimes smaller scales by local governments. So Gallup World Poll, I think, is the only global large-scale survey where they ask questions about the migration intentions. But in general, the large-scale surveys do not specifically target migrants, but they do have some questions about migration or migration background, or they have specific modules, like for both EU-SILC and LFS, there are two recent, let's say in the last 10 years, modules on the migration background. So what we measure with these data is, when we talk about the migration statistics, we do not talk about hundreds of different types of variables. We are talking about immigration and emigration. So we want to see how many people came in, how many people went out for like residence purposes, so inflows and outflows. Then we had the granted visa, the aggregate level of visas for different reasons. Like visa is the most detailed one in terms of the migration driver, because we do know if their primary goal is to work, then they need a work permit, or to unite with the families, then it's a family unification visa. We have study visa, and we have others, and we have asylum applications. And then we can also talk about the migrant stocks, like country of birth and country of nationality. In some cases, in some countries with migration background, what they do is they also try to go the descent, like if your grandparents are from that country or where they were born, but we can go so for up to 2 generations. And what is the main point that we need to think here is that in all measures that we are referring to, which are based on usually the administrative data, we are talking about a specific time frame. So because these are the aggregate numbers, and we usually refer to annual data, I mean, the asylum applications can be found really on monthly basis, but besides, most of the data is a yearly basis. And what we do see is that if we are talking about the data from 2019, we are talking about who was there on the 31st of December 2019. So what is happening during the 1 year is very difficult to capture with the traditional data. And as well, with the, like visas, we have a category which is called other. I didn't put it here and you rarely see it, but the other is really different for every country. It might be the people, like who forget to renew their residence permit. They could be the people who are under temporary protection but not granted asylum, or it could be all complicated, like procedures. And what happens is that we ignore the other, but other makes the 30% of the total applications. So the drivers, the others are already making almost 1/3 of the people, the incoming people, but we do not see what's really going on there. Having said that, like we have published recently a very long and extensive report with enormous and very great contributions of different partners from our project. It is gaps in migration statistics. By the way, it is not only about the statistics. The first part is devoted to migration theories and how to capture, or are they sufficient to capture the contemporary reality of the migration dynamics. And the second part that I will refer to today is the main gaps that we discovered in the migration statistics in general. So we do see that the definitions are problematic because we refer to either the nationality or the country of birth, but sometimes it's getting more difficult, especially considering the families, for instance, with the mixed couples, or like the mobility. People are born different areas, but it doesn't make them ethnically different than their own country. Or drivers, as I already discussed, it's not that easy to understand why people are moving, when they are moving, and also, especially for the intra-European migration, like the records are pretty limited. And then the demography, like especially education, we do not have, it's very difficult to get disaggregated data on education. In most of the censuses in the EU, the education data is available around 50% for the whole entire population. So they're working on improving it. And there are some exceptions where some countries doing pretty well. But in general, even education is not there with the gender, especially with some specific groups. We do have some assumptions or overrepresentations or underrepresentations. And we do have hidden populations like travelers or Roma people or homeless people. And then geographically, most of the data is available from the UN. Yes, we do have everything, but on a very aggregate level and a new level. But then for the EU, we are really, we see that for some countries, everything is really, elaborated. For some cases, it's not. And temporality is the main problem. Like we do have the data, which is almost 2 years old. And it is not only for the data of the national registers or census data, but it is also valid for the surveys, because what we mean is that if you're working for example, EU-SILC or LFS, EU-SILC is the European Survey for Living Income Conditions Survey, and then the other one is the LFS Labor Force Survey. Like if you have the data from 2019, you have to know that that data was collected in 2018, and the sampling frame was based on the previous year's data, which was 2017. So today, in fact, you are talking about the representativeness of the population of 2017. So why I mentioned these gaps is that in some of the cases, not maybe fully, but partially, alternative data sources and the techniques might help us to improve. So can big data really improve the migration statistics? We do see that there are a lot of studies where they help, or they are at least checked for robustness. So they work in some cases as well as the traditional data. So when we say big data, especially for the migration studies, we do see that there are three main types, like the big data of the mobile phone data records, internet-based data, and social media data. But we do also have the financial big data, which is the banking transactions, remittances, and then the qualitative big data. These are the archives, oral history archives or text archives, media archives. So these are also big data. So we will go slowly over those. When I'm talking about the mobile phone based data, the abbreviations we use are usually CDR, which is call data records, and the other one is XDR, which refers to your connection to internet through your mobile. But we also have mobile money transfers like top-ups. And for internet-based data, the usual suspects are Twitter, Facebook, Instagram, LinkedIn, so the social media. And we also have Google or Yandex, like the search indices. We also have IP addresses like emails, where you send your emails. So internet-based data is a very broad one. And the sensor-based data is usually the satellite data, and it is called Earth observation data. And for the European case, we always refer to Copernicus program by the European Space Agency. And Sentinel-1 and 2 is a public data which is available to researchers for free with the proximity of 20 meters in general. If you need high definition data, you can still have access, but you need to apply, and especially if it is a funded project, you will not pay data. So here I would say that the Earth observation data is easiest to access because it is there, but it is the most complicated one to process when compared to the others. So I will give you some examples of the previous studies. So of course, not all of them, but to show you how they utilized different types of data. And you will see that let's say social media data has been used most densely because it is easy to access, easy to download, and has a lot of potentials. That's why you will see a lot of studies with especially Twitter data and Facebook marketing data, which means API. In fact, it is also available to everyone. What people do with the Twitter data is that you can either analyze the users, like where, because when you're a Twitter user, you define where you are. So of course you might lie as well, but there is a location, so it is geocoded. And then you can also add more like keywords, you can have lists, or you can analyze the tweets, like we hear the TT, like top tweets, the hashtags. So the content analysis, the sentiment analysis with the hashtags is also possible. So you can analyze different things in Twitter. You can even analyze the networks of people, whom they are following, who is following them. And the first study with Zaccani et al., Emilio Zaccani is one of the, I think, pioneers in the use of big data for mobility research. He's the director of Max Planck Institute of the Demographic Research in Rostock. So the first, in 2014, I think everything started in 2014. And then inferring internal and international migration patterns from Twitter data. What they did is they used almost 500,000 users' data from Twitter, and it is for the OECD countries. And then it was for almost 2 years. And what they tried to do is they tried to see if, looking at the geocoded data, if it is possible to see if people move. And then they also wanted to check the robustness. So they wanted to check if the indicators they developed or the variable that they developed is valid because they checked it with the official migration rates. So they did different approaches. And here there is one of the outcomes. You see that, the mobility rates for Twitter users on the left-hand side, and you have the time, and you do see that what is the average OECD for Mexico, USA, Germany, Japan. So they try to see, if these trends are trustworthy. And they found that they were. So it was the very first steps of using Twitter data to analyze mobility. So of course, here we are talking about the mobility of Twitter users. We will discuss the selectivity bias later, like who uses Twitter. And then there is another study by Stade et al. In 2014 again. This time they worked with LinkedIn data, because LinkedIn data has information about education that we do not have for many migration measures. So what they did, they analyzed the career histories, because you do already have your degrees on your LinkedIn account and where you work, where you studied, so the name of the institute or the company is mentioned, so the location can be found. So you see that they did even very detailed analysis of with a bachelor's degree or with a PhD, or if they are from the top universities or from a STEM field or non-STEM field, the students. So they tried to see, like from 1990 to 2012, they tried to see the probability of migration, like what is the probability of someone with a PhD degree to move out from the United States. So then there is another publication. This time we are talking about the Facebook data. The Facebook API refers to the Facebook marketing data. What we mean here is that if you go to Facebook, if you Google Facebook API, you will see that Facebook allows for the companies who would like to advertise on Facebook to detect their customers. So you can say that, oh, I am selling chocolates and I would like to target women between 20 and 35 and living in Eastern Europe. You can already get some estimations. So this type of data can also be used for research purposes. And what they did is they tried to see the expats, but this time instead of a flow, they wanted to estimate the stock, so where people live, because in Facebook, it's not that easy to track if people change their residence. So after fitting the model, they wanted to check if it fits with what they have in hand. So they checked it with the American Community Survey data, and they tried to get rid of the biases. And what you see is that, like here, it is the, they tried to see counter comparisons, like you will see on the very high, like Mexicans in Canada, Mexicans, Filipinos. So you will see that there is a technical methodology behind it, but in short, they were successful to estimate the stocks, just by using the Facebook advertising data. And another study is a recent one. It is a report by the Commission. Although it is called measuring labor mobility, yesterday I was talking about the labor migration, and I also criticized this report because it tells us a lot about the EU mobility, but there is a huge assumption for the economic reasons. So they assume that most of the intra-European mobility is based on labor purposes, but besides, the methodology and the estimations were pretty accurate. So what they did is they used several data sources, and they wanted to see these if this georeference social media data can be used to understand the no stock. Why nowcasting is important? Because if you remember, we said that most of the data is old. So we always have a time lag with the official statistics. So, and it is also difficult to capture intra-European mobility. But with this one, they could estimate the migration flows, and also they could also check the official statistics. So they used big data from social media, Facebook and Twitter, and then they tried to combine these data with the traditional data sources. So they calculated some estimates for specific EU movers, not only for, like in general. And then they checked these with the official statistics. So, like if this extrapolation worked or not. Of course, it did. Then I'd like to give you an example of the internet use. So this paper with Burma, it is published in 2020, but they've been working on the paper, I think, since 2018. It is the one where they use Google Trends data. So Google Trends Index is an index that is developed by Google, and it is public, so you can get this data. It has this high frequency time series data for these searches. So, like assume that in Poland or even in Krakow, who searched, you can't know who, but what was searched the most, so which words used. So what they did is they started with listing keywords. So they ended up with, after several eliminations, they had around 50 keywords. Then they translated these keywords into different languages because they're not doing it only for one country. So at the end, they of course, they worked with some social scientists because the words, the keywords should be related to the migratory intentions like passport, asylum, embassy, social assistance, like refugee. So they really checked a lot of things, and then they translated the official languages, and then they found that their measurements are consistent and representative, and it is beyond the EU. So in this case, they could find a lot of information on a global level. So they could also make short-term predictions because the Google Trends data is, you can even get it on a daily basis. So they could find short-term predictions, and again, claiming to overcome this timeliness, the challenge of the existing statistics. So they also try to improve the conventional model. So what they did, like they modeled the migration as we usually do, with some regression analysis, and then they introduced their indicators to see if the models were improved, and they did. And so, for instance, what you see here is that the comparison of different models. So when they have a basic model, so with blue crosses on down, you see that these are the basic model with GT is their, let's say, the indicators. And then if you go, they could also provide insight about the non-sample. So having this migration, and they also checked the economic drivers. So they found that the models with their new developed indicators worked better on average. So they explained more variance in short, in terms of the moving, and the errors were also decreased. So Hughes et al. Did it for several of them. And why I included this study is because they came up with a conclusion saying that if you compare different social media data, LinkedIn is found to be the best option for labor migration. I think it's not rocket science to understand why they come up to that conclusion, because LinkedIn has the most detailed information about the career histories and the education. So they said, yes, it has a potential, but we have to keep in mind that we only have mid or high skilled people on the LinkedIn, so it couldn't provide us any information on the low skilled labor migration. And after those, the satellite images is usually very abstract for many people to see, but how it could be really used. So European Space Agency had a feasibility study a couple of years ago. Now they started a real one, and it's called Big Data for Migration. And what they try to do is they try to understand if satellite imagery can be used to identify internal displacements, or what is happening after a disaster. So in Europe, we do not have so many natural disasters, luckily. However, in South Asia, in Latin America, and even, like the east coast of the Northern America, and especially Africa, we do have a lot of disasters and emergency situations. And it worked pretty well, especially on the case of Africa. Here you do see that this figure illustrates what they found at the feasibility study. So they have the departure points, like the traces, border monitoring, EU borders, where the conflicts are, and internal movements. So they could capture a lot in Africa. But of course, here they were not talking about exact numbers, but they were able to detect how many refugee camps or tents were settled in a specific region and when they moved. So they could think about the trajectories. However, because of the confidentiality and privacy issues, so they were very careful with working with the aggregates level data. And the natural disasters in particular have been studied a lot, but not only with the satellite data, but also with the mobile phone data. CDR seem to be the most promising if you look at from the methodological perspective for accurate migration measurements, but mobile phone data is the most challenging one due to privacy issues. And it is also very tricky to get the data because the data is privately owned like the others, but they do not have, let's say, the advertisement or marketing data. So you really need to consent from the companies, but it doesn't mean that the users give you consent to use their own data. So the Blumenstock wrote in 2012, and he wanted to use mobile phone data records for inferring the internal migration data. It worked pretty well, and they worked with Rwanda's primary telecom operator. They had more than 1.5 million subscribers, so it was for 3 years. And then you are going to see that they used two types of data. The first data was the time-stamped record, which means like they followed the calls, like assume that I'm in Belgium and I'm calling Poland. So they could see that there was a call in Leuven to Krakow, like at today 11:03. So the second one was the towers, because with the mobile phone data, it's not only the calls, but also the transmitters that we can use. And the transmitters are geocoded. That's how they know where our calls are. So assume that I'm living next to a mobile phone cell, which is 50 meters from where I live. So they could also see the closest tower for that transaction. The transaction could be a message or a phone call. So I really suggest you to have a look at the paper, because they have enormous information, very detailed ones. And I just put there the sector because I think it was very important. They did it for education, for everything, but you do see that they try to see different occupations like farmer, teacher, student, unemployed, and transport. We do know that, truck drivers are always the outliers in mobile phone data, but they could check the 3 months, 12-month migration. So they could really calculate a lot of indices based on their migratory movements. So what was the challenging part about this paper is that when you read the paper, you will see that they even tracked a couple of people to see if this data can be used. And they got a lot of course, ethical critics. And one issue that we had to think about the mobile phone data is that I think in the European Union, we do know that the Estonia, they are working very closely. University of Tartu, they work very closely with the telecom operator. In Italy, they do, and in Spain. But besides, almost all of the mobile phone data applications are in the not developed or developing countries, where these privacy standards are way lower. So you will see, if you just Google with the mobile phone data migration, whatever, you will see that most of the countries are Rwanda, Ivory Coast, like Somalia or Indonesia or Philippines. So you will see that most of the countries are out of Europe. And they had so much information about people, and especially if you can go to smaller scale, it is really possible to come up with ethical issues. But I'll discuss ethical issues at the end in detail. So here you do see that we can also use mobile phone data in emergencies like COVID. And why this epidemiological this pandemic became part of mobility? Because it spread with mobility. That's why most of the studies also considered mobility, cross-border mobility, and there have been a lot of studies, and it is the first time that you would see that almost in every single European country mobile phone data were used. So the operators allowed their data to be used. They even allowed tracking, so people were tracked. I can tell about the Belgian case. During the lockdown, you were not allowed to move out of 2 kilometers of where you live, and they were tracking the mobile phones if you do. So in this study of Pepe et al., it's a very long authors list. So they tried to see if they could follow the mobility changes in Italy. So Italy was one of the first hit hard countries, and they worked with 170,000 users. They called them de-identified. What it means is anonymized. So nobody knew who that person was, but of course they had a lot of information about the user. So they had before, during, and after the outbreak. And so they had this daily time series. So they had the origin destination movements. So between the provinces, they had the radius of where they went, and they had the average degree of spatial proximity. So whom they are calling the most, like they could define your network, and then they also calculated how far or how close geographically you are to your network. And here you see that, the colors refer to different regions of Italy, like north, center, and south. And you can see the census and users, and they could find a very high correlation. So their measures really are consistent with the census. So they said that it's trustworthy to use that data to estimate the mobility of the people. So now, after discussing what has been done, I know that I'm kind of out of time, so I will be quick, and I would like to also discuss about what we are doing and what we will be doing as the Hummingbird, because Hummingbird project is a Horizon 2020 funded project, and we aim to understand the migration scenarios in short, and which includes the nature of the flows, the drivers, like the patterns, motivations, geographies, and also, when possible, come with the forecasts. So we are 10 countries, and then we have 16 partners, and I'm very proud to say that we do have industry, the companies, and very large NGO networks. We're working with Caritas International, and we have CHILD from Italy. We have European Network of Migrant Women, and we also work with an ERIC. Which is not here is that we also have unofficial partners. We are working very closely with several municipalities, like in the Belgian case, we're working with Brussels. In Istanbul, in the Turkish case, we are working with the Metropolitan Municipality of Istanbul. And so it's a mixed methods with qualitative and quantitative. I really want to emphasize this because we really believe in the complementarity of different approaches. So instead of offering big data as an ultimate solution, which is not, we say that how we can complement the shortcomings of the existing things when we are combining the qualitative and the quantitative understandings. So what we are doing in the Hummingbird is, the first part is we are also using Twitter and Facebook data to estimate migrant stocks. We are coming with a little bit more elaborate analysis because, for instance, with the Twitter, we are not only estimating the nationality of the users, but we are trying to estimate the nationality of the hashtags, like to see, I'm living in Belgium. I'm a Turkish background. Do I tweet in Turkish, in Belgian, in Flemish, or French, or in English, or what is the content of my hashtags? So we would like to see the effect of social networks. We will, based on the gravity model, which is used a lot in migration studies. So, like you tend to go where your network is. And then we will also analyze this political and the policy changes, like Brexit in particular. And then we also have another, we do this for the migrant stocks, but for the seasonal migration, I think we have a unique data set, which is the air traffic data. So what we do is, it is unfortunately till 2018 that we have, but it is all for 8 years. So it is for 239 countries, and we have over 45,000 pairs, so the flights. So we would like to see the time series differences in this data. We are going to analyze who goes where and when. And in this way, we also would like to see, like if we can see any pattern for the, let's say, the seasonal workers, because seasonal migration has the tourism, but it also has the like farm-related or season-related labor workers. And in addition to that, we are working with the CDR data. It is almost ready now. What we do is, for the with the call data records in Istanbul and in all other Turkish cities, we are analyzing the data for 1 year in 2019. We would like to see who, especially from the refugees, who goes where. We do know that most of the refugees are moving to different countries where there is agricultural sector, and they work as seasonal migrants. And then with the COVID, we changed our case, and we wanted to see the impact of COVID on the mobility of the seasonal refugee workers. And we do have an indicator in the data if a person is is a Syrian, so we can know their background, and we can even do it for Afghans and for others, but we do not work with individual data. What we see is that, let's say in Istanbul, there were X thousand Syrians, and the next week we do see them, or we can even check it daily, we can see them in, let's say, Ordu, where they collect hazelnuts, and we see how long they stay, that number stays there. So we are working with the aggregates data. So for the brain drain and highly skilled migration, we are using, in fact, two different approaches. The first one is with the LinkedIn and ORCID data, but in the second one, we are working also with scientific publications. So we are integrating this LinkedIn and publication data, and we would like to see within and between the EU and the rest of the world who goes where. And then also we will try to see the drivers, like if they change countries, if they change sectors, like we try to understand if they get a promotion, that's what we try to see. And of course, we will also check for the networks. And then with the scientific publications and also affiliations, this paper is about to be out very soon by Laura, Jyoti, and Alina from University of Pisa. They estimated the global mobility of academics. By using the data in the publications, because when you have the title, but then you have the authors and then the affiliations, and they follow the changes in the affiliations. So we are also using satellite data, and Somalia is our case, and we are working for a period 2015 and 18. We finished the first phase in this one. So what we are doing is we are developing maps, firstly, like we are developing land use and land cover and the vegetation indices, because we do know that especially in the Africa, like land use is very important for agriculture. So especially in the villages, if people do not grow crops, they don't have money, they don't have food, so they are pushed out. So now first we are now developing the indices. What we are doing, the next step is we are going to combine them with the socio-economic data, so to see where these people go and what are the impact of the, let's say, cyclones or droughts or floods in that specific area. And we are working on a very smaller grains, like in Somalia. And then we are working with the Sentinel-1 and 2, the satellite images, and we would like to see what is the influence of these environmental factors on migration. I'm very careful that I'm, there are different opinions about the environmental migration, but I'm on the side where we cannot call them environmental migrants purely because it is the environmentally induced, it's very intersectional. You cannot talk about just environment, the only reason making people move. And then we are working on the refugees. In our case, there is Istanbul. We are working with the CDR data, but we are also using the satellite images. So it's a new data, and it is for 1 year, 2019, but with the COVID, we are also using 2020 data. Here, I will talk more on the ethics and OPAL. Because we are using the anonymized and aggregates level data, and OPAL is a spatial system that we develop with some colleagues from the DataPop Alliance, which allows us analyzing the data without having access. Because what we want to do is, at the Hummingbird, we would like to allow industry and research and government authorities collaboration where we can overcome the ethical aspect, because the data going out of the company is a big issue, and we would like to find a way to facilitate and to operationalize the use of data without leaving the company's service. And what we do is, I think we do a lot of things, but one of the interesting things that you can find relevant maybe to your studies, we are combining CDR and night lights. What it means is that, like in the Istanbul case in particular, there are a lot of refugees, and not all of them are registered for the residence. So they are, like in the statistics, you do see them in Turkey, but you don't know where they live. So the domicile is not registered. So what we are going to do is, we are working with the antenna traffic data. So we divided the day into 3. So we have this, 8 to 4, 4 to 12, and 12 to 8. So we assume that between 8 to 4, these people are working or studying. So they're spending their time. From 4 to 12, it's their social and daily life. And from 12 to 8, which is the most important part for us, we assume that that's where we get the signal for these people are where they live. So we are going to combine this map with the night lights, because night lights is a data which is available by NASA and NASA. What we are going to do is we are going to overlap and to see, if we do see lights where it is not really a residential area, because it is known that, especially in the Turkish case, most of the Syrians and the Afghans as well, the refugees, they are living in abandoned buildings or some industrial area. So we would like to see, like with some reference variables like the migration settlements or economic prosperity, we will see it in a JS visualizer, which is going to give us an idea about where these people are living. So this is also an example for how you combine even different data types. And in this case, the Metropolitan Municipality of Istanbul is also willing to help us. So they are also interested in the results, and they are going to provide us blocks level, at district level registrations, and we are going to compare with the official statistics as well. So I will share my presentation. So these are the references, and there are some further readings which might be interested in. And thank you very much for listening. And I don't know if we will have the Q&A at the end. Probably now Carlos will continue.
Okay, thank you so much, Tuba, for your fascinating and great insights on the big data science and application to migration. I can see it's really a huge potential in what you're doing. I think the time for the comments and for the questions will be afterwards. So at the moment, if anyone has a question or comment, you are welcome to write in the chat. And now we will give floor to Carlos, who will complement the research. I will introduce quickly Carlos. Carlos Arcila Calderon is the associate professor at the University of Salamanca in Spain. He's the principal investigator of the European project Preventing Hate Against Refugees and Migrants, and also the National Project Data Science in Spain, Knowledge and Public Perception of Big Data and Artificial Intelligence, as well as the proof of concept development and evaluation of hate speech detector in Spanish. Carlos is also involved in a couple of other research projects which are linked to the topic of migration. His research interests are mostly focused on ICT adoption, media, social media analysis, computational methods, and big data. So today he will be talking about a fascinating topic of how computational methods can help us to analyze various kinds of data to better handle the issue of integration of migrants in European society. So Carlos, the floor is yours.
Thank you so much, everyone. Thank you for the introduction. I would like to know if my screen is correctly shared and you are seeing my slides.
Yeah, we can see.
Okay, so thank you very much for the invitation. I also honored to share with you some of the experiences that we have had in the last few years about the exciting field of joining big data methods and also migration studies. Also, I think the presentation made by Tuba is excellent. It's an excellent overview of many of the things you can do in the field of computational methods, of machine learning, of big data when working with migration studies. So my presentation will be about the implementation of some of these techniques to a specific issue, which is the integration of migrants and refugees. And I will focus more on some specific cases, so you can see probably a little bit more what is behind a big data study, a big data approach when you have to work with migration problems or migration issues. So for these, I will choose two different approaches. So I will work. In general, I will show you how to apply machine learning, which is, as you know, is a branch of artificial intelligence that we normally use in big data, and we'll try to use that machine learning approach to two kind of different data that already Tuba referred to some of these data. The first part is unstructured data, which means that we can apply machine learning to text or images or videos for example, in social media or parliamentary speeches or video records. So I will tell you a little bit about what we can do and what actually we are doing when collecting and modeling data from Twitter. Specifically, my case of study will be the large detection of hate speech against migrants and refugees. And the second place, I will show you how to work on something probably that you are more familiar with, which is structured data. This is databases, surveys, official statistics, and how to implement big data approaches, and specifically a machine learning approach to work with survey data. In the case of study, I will show you how to run or conduct predictive analytics over surveys, specifically the Eurobarometer survey, and then try to scale these models to what we call synthetic populations, which is an artificial population that we create to extrapolate our results to different areas. So, as a little bit, as a little introduction, you already know that we have right now a very, very important context of migration all around the world, and especially we are in Europe. We know how it's been in the last year, the arrival of migrants and asylum seekers, and for the next few years, we are facing probably a very important challenge is going to be the integration of refugees or integration of migrants in our societies. So probably one of the problem we would like to solve is what is the probability of acceptance of these receiving societies, because we've been working during years in migration studies with some different variables, like, for example, the economic level of the society to receive migrants. We already know that a city or a society where the resources are scarce is not probably a good environment for a migrant, because we are going to compete for those resources. But there are other indicators beyond these economical indicators that we have to take into account in order to really predict this probability. So there are some ways to measure these attitudes, like, for example, in surveys, or also we could measure the attitudes of people by reading their contents of social media. But the case is that we don't have enough data or clear or organized data to have enough inputs to detect or to know which are the cities that are more likely to permit or to allow social integrations of migrants and refugees. So there are a lot of previous studies in this context. So I'm going to skip many of the slides because probably you already have some very good introduction with Tuba. So the idea that I want to give you here is that to measure the level of acceptance of migrants and refugees is a very hard task. And so far, we only have some of these measures by a national level, and in some cases in a regional level, using surveys. But we still have a gap to fulfill in the field of local levels. For example, we don't have enough survey data in no local levels of Europe. Let's say, for example, NUTS 2 or NUTS 3. We don't have that data, so we don't know what people think about the migrants. We have some geolocalized data, survey data, like, for example, the Eurobarometer, but some of this geolocalized data is not available, and some of them is available, but is difficult to access to. So this is the gap we would like to fill with a big data approach. So as I said, I'm going to show you two big data solutions to estimate the probability of acceptance of refugees in European regions at the regional and local level. The first one would be supervised text classification to detect hate speech. And the second one will be the use of machine learning and synthetic populations over survey data. So all these approaches will help you probably to come into a field which I find myself very exciting, very promising, which is the database migration planning, which is probably what we finally want to, when we are talking to big data migration. We want the data to tell you something. Of course, we already know, as Conrad introduced, that we have biases in data, we have biases in the algorithm. I mean, there are many challenges we have to still to work on, but the field of database migration planning would help to governments and to policymakers to make migration easier, or to make the life of migrants easier when they have to come to a new society. And a good example of what some past studies that have covered this kind of planning, or this kind of approach to let policymakers make their plans, is some of the ones that already Tuba mentioned, for example, the one by Sageni, but others like Hawalka or Lamana more recently, who have used social media data to establish patterns or to predict, for example, job success when migrants are coming. There are other like the one of Bansack, and so all these are reference. I will also share my slides, so you can check of them if you're interested in this area. I will talk a little bit in more detail about these solutions, and you'll see what is inside a big data approach. So the first of them is, as I told you before, supervised text classification to detect hate speech. This is a very, very challenging task, since we know that online hate speech has increased in the last years, and online hate speech or hate speech in general is a very, very good indicator of how much society are willing to accept newcomers or not. So the degree to which the online hate speech can be found in a society is related to the degree that this society wants to accept or not the newcomers. So there has been an increase of this hate speech, and we note that monitoring this hate speech will also contribute with other parts of society, like for example, countering these kind of discourses, and then make our societies more healthy, and to promote the integration of these migrants. So it's difficult to measure hate speech, and more difficult with the big data approach, because there are like many levels. There is illegal hate speech that normally is on the top of this triangle, which is the direct incitement to violence. So we can find some of this kind of messages against migrants and refugees, but probably it's just a very, very small percentage of it. We normally will find more discrimination or more offenses to individual collective sensitivity. So we can use an approach to detect all these levels of hate speech in order to predict integration at a scale in a regional or local level. So this is, I think, very justified, because we know that speech is not only that remains there in the field of the discourse. Once we speak, as you know, and the philosophy of the language has stated this for years, the speech is by itself an act, and moreover, the speech drive the behavior. So there are a lot of studies in the recent years that connect the speech with the behavior, and especially for example, the online hate speech with the hate crimes in the real life. So by detecting online hate speech with a big data approach, we can not only prevent hate crimes, but also we can estimate how the feeling in a society towards migrants and refugees. So there have been so far many prototypes to detect this online hate speech. We can find many by governments and by academics and by also by private companies like Facebook or Twitter that have implemented prototypes or algorithms, but there have some limitations. I'm going to show you how we can address the limitations so we can build a better classifier. So what we've done is to build that detector using Twitter data with trying to get messages from that contains xenophobic or messages against refugees and migrants. And we've done all these at a scale using a supercomputer, computer infrastructure. And the first thing we have to do was collecting data examples. So we have to work for many months using some manual classification. So the first step in a big data approach for text classification to analyze social media contents is to have some manual annotated data. So this work or this part of the job is very interesting, since many of the limitations of the previous prototypes are related to this part, because we can do very technical work in big data, but if we don't have good examples, we won't build very good models. So the first step is just to collect these messages, and for that we in our case we've been working with many coders that are collecting data and manually annotating what is hate speech and what is not against refugees and migrants. Of course, we also use other targets, like for example LGBTs or tweets that contains hate speech because of political reasons, but our main focus was on hate speech against migrants and refugees. And for that we can use a lot of specific techniques referred to text analytics that are used in big data approaches. We can talk in general of natural language processing, or we can talk about specific techniques like sentiment analysis that Tuba already mentioned. We have different kinds of sentiment analysis, like for example, lexicon-based sentiment analysis, which uses dictionaries to detect the sentiment in a tweet, or we can use supervised sentiment analysis, which also require initial samples to develop the model of a sentiment. Or we can conduct techniques such as topic modeling, with the text that automatically detects the underlying topics in a large amount of text. So all these techniques, or text analytics techniques, can help you to process the data and then to produce the models. And these predictive models will help you to monitor at a scale in different languages or in a distributed way the specific places where hate speech is being produced. And this is what probably already Tuba mentioned about the capability of Twitter to get some geolocalization information. So we can detect which specific cities or regions are producing more or less hate speech. So this is exactly what we are doing right now at a scale with a big data approach. And for that, as I told you, we are using this, what we call supervised classification, which if you're not familiar with, I'm just showing you a very intuitive figure where we can clearly understand what we do when we model with supervised classification. We have the data with an algorithm, and then we produce a model. So there are many different algorithms in the work of big data. So if we want to get or to know a little bit about this algorithm, you have to come into this world. This is a little mathematical, but even if you don't have a mathematical background, you can easily understand, because some of them are very similar to what you already know, like a regression approach, or for example, you have logistic regression of an algorithm. We have some more sophisticated algorithm, but in general, we'll have different mathematical approach to do this classification. So the first thing, as I told you, is to have very good material to build the model. So in this case, we have filter, analyze, and manually annotated a lot of messages in order to to get the models. We have checked things like reliability, intercoder agreement. So we have built good models for this project that is called Stop Hate, and we have found some small part of real hate speech. And with this small part that you can see here in red color, with that small part, we can build very good models, even when we have a small a small amount of messages, but these are very good examples of what we consider hate speech. So what we did is we conduct this classification with shallow and deep algorithms. In the first place, we run like logistic regression, naive Bayes, or support vector machines, where our algorithms that are what we call shallow, but also we include, and probably this is the most interesting thing when working with unstructured data like images, text, or voice, is to work with a deep learning approach, which is what we know, like a neural network, or in this case, we specifically use a recurrent neural network. So these kind of models, these kind of algorithms help you to model the patterns of very complex data. So probably as we see later in the survey, we don't need this kind of complex algorithm, because most of the relations we are want to detect are linear, like we are using regression. But when you are working with video, with audio, with text data, you will find a lot of complex relationships that are not easy to be modeled in a linear way. So that's why we're using a deep learning approach in order to capture all the complexity of the data. So this is the result of a classifier for hate speech, which can help us to extend this work to predict at a scale the amount of hate speech. You can see here, this is in big data and machine learning. We normally would with evaluation metrics. And these are some of the most popular evaluation metrics, like accuracy, F-score, or area under the curve, which are, as you can see, they produce good good indicators to know that we can develop very accurate models in order to predict or to classify text as a scale in order to make predictions. So the next step in this part that we're now conducting is to use this detector in order to produce early warnings in order to set, like, for example, alarms, which are the cities in Europe that are producing more or less hate speech. So this will constitute an input, a very clear input of social integration in a city. So this is like the very first solution that we found that we could use for understanding social integration. But there are more things. So we have more solutions that we can apply from a big data perspective, not only using unstructured data or social media data, but also using traditional survey data. That is something that Tuba already mentioned, of some of the survey that we have and some of the statistics we already have. So we can employ these statistics, this structured data in order to generate new knowledge using machine learning approach of a big data approach. So the first thing is to, or the second solution we have is to use what we already had in survey data, which is questions that directly ask people how much they agree, or in which to what extent they agree that their society should accept or help refugees or migrants when they come. So this is a question that was included from 2016, yes, when the crisis began in the Mediterranean. So most of the surveys in Europe began to include that question that directly ask people if they want to help people, to the government to help migrants or to help asylum seekers or not. So with this question containing a survey which is representative, with normally probabilistic surveys, we can use this general national data in order to extrapolate that general results to other geographical levels. But as we know, we don't have the answers to those questions in the survey to every specific city. And I mean, we have representativeness for the whole country, but not representativeness for every specific city in Europe or most of the world. That, I mean, most of the country, we don't have that. So for that, we have to build models based on machine learning in order to create models that work for different cities. And for that specific task, we have to build artificially that cities using also machine learning, or what we call synthetic population, which is an artificial population built on a priori information that we have about those cities. So what we did in the study with using this approach is to collect data from almost 3 years from the Eurobarometer in order to model a question that was included there, which said that ask the people if the country should help or not refugees, and using that specific question and the socio-demographic characteristics of those persons that we don't know the name because it's an anonymized survey, we built the models for to understand how socio-demographic characteristics explain the acceptance or not of migrant. And so in this sense, we could say that there is a good indicator for social integration. So we did many things like create the matrix for the predictive analytics, and then recode all the variables in order to work good with them in the machine learning approach. And then what we did is to apply the similar algorithms that we apply in the text classification, but we didn't use deep learning because, I mean, we are working with survey data, so we didn't expect that to be that complex to model. So we use just like, again, logistic regression or decision trees or random forest or nearest key neighbors, which are shallow algorithms. And we model the probability of acceptance of refugees and also of migrants, but I'm showing here just the case of refugees in every NUTS-2 of Europe, which means there are something similar to regions. And we are now conducting this very same study in Belgium with Tuba, but working at a very, very local level. So more than NUTS-3, we're working at the level of a district and city. But for now, what I'm presenting you is the level of region that we didn't have the information for that time. So we create the information based on surveys. So what we did is we took all these variables from the survey, the target variable, which is the acceptance or not for refugees or migrants, and the socio-demographic variable, which is, for example, the countries, if the person is married or not, the gender, the education, etc. So only with these variables that probably are not the ones that explain the most this behavior, but only with these variables, we build the models and we estimate the accuracy of those models. And then in order to estimate not only that probability, not only for artificial individual, but for a given city or a given region, we create artificial populations, which are synthetic populations, in which we could apply for each of those artificial individuals, we could apply the model that we generate for the initial individuals. So for that, we use this traditional some traditional techniques for synthetic populations, which probably in social sciences are not that common, but in other areas like, for example, transportation studies or other areas different from ours, they're popular. And we use a priori information from the census data in every NUTS-2 of Europe, and then use this a priori information to artificially create this population. So in few words, what we had like a list of 10,000 individuals for each of the geographical regions, and this individual has some a priori characteristics or a priori features, and for those features we predict the probability for each individual to accept or not refugees and migrants. So with that approach, that was a little bit very technical, I show you a little bit about the code we used there. We could make the extrapolation at this regional level. And so we had many results. For example, we have results that we could compare the countries, which countries accept or not more or less refugees. But this is not new, because we already had that from the data. We already knew from the survey data, we already knew which countries were more or less prone to, were more or less willing to accept refugees or migrants. But the interesting thing was to go into the detail of the region and then go to some data that we didn't have before the survey. So we went to compare regions. For example, this what I showed you on the slides I think is Spain, Italy, and Greece. And so what we can see here is, for example, in the case of Italy or Greece, or even in Spain, that the most populated regions, which are, for example, in Greece is Athens or Attica or Thessaloniki area. So the most populated, or the areas where the big cities are, were the ones that were more able or more willing to accept or to help refugees. And some other areas, probably more rural or with less experience with migrants, were less less willing to accept refugees. So what we found here is something that we didn't have from survey data, and that of course we can complement with other sources or with other inputs, even inputs like the hate speech in those regions. And so this is new data, what you didn't have. So what we used was to use big data approach. We use a lot of data, but just to get a solution for a very specific case in a region. And this is going to be probably more useful when we go more into the detail of a city or the detail of a district, which is obviously more particular and more difficult to get. So as final remarks, and in order to finish, and I think try to keep on time, we can get new articulated data sets based on big data. So we can generate new data that didn't exist. So the examples that I've shown you, here that use computational methods, actually what they do is producing, again, new data, new indicators that you can use in a migration, for example, in a database migration policy, or you can use to probably understand migration patterns, or you can use to show policymakers how to act in the case of social integration. Of course, as we've been telling, there are many limitations. There are many other indicators that we can see. There are other approaches or other machine learning approaches or other big data approaches that we can still use, like those that Tuba mentioned about telephone data or satellite data, or even just other, for example, in the first case of hate speech, other social media inputs, not only Twitter. As you know, the academics were using Twitter a lot because the API allows us to easy access to the data. But we can use, for example, YouTube videos or news comments or Instagram pictures using video analytics or image analytics in order to get also very good and valuable information. The importance here, or what I think that this predictive analytic or big data or machine learning approach is good, is because we solve a problem. Probably if you see big data approaches, most of them are not aimed to describe or to understand data, because it's probably not what we do in big data. Probably if you want to understand some of the patterns of the model, you have to use another approach, and actually you have to use more theoretical or more other kind of approaches. But when we use big data and we use algorithms and we use this supervised classification, probably the understanding of the patterns goes to a different place. And the important is to solve a problem, to get a solution, to get an indicator, or to get new data with that big data. So this is what I show you here in these two cases, with the first case with hate speech or radical speech against refugees and migrants, and the second place by using the very answers, the answers of the citizens of Europe, in order to extrapolate the answers to collective in different regions. So thank you very much, and I will be open to answer any of your questions if you have any. Thank you.
Thank you, Carlos, so much for your talk. So now we are beginning our Q&A session. We've got a couple of questions already. So the first question will be asked by Veronika Klocnowak. So Veronika, if you could unmute yourself, and if you want, you can also switch on your camera, like that's optional, and you can ask your question to Tuba.
Okay. Hello. Thank you for a wonderful and very wide introduction to how to use these different types of data. My question is specifically about the use of OPAL in mobile users location analysis. I have no idea what is OPAL, but you mentioned, if I heard correctly, that it allows you to analyze data without having access to this data. So if you could develop this idea, and how does it make your research more ethical, as I understand, than the Rwandan case of locating mobile users? Thank you.
Well, thanks a lot. Yeah, it's I tried to, like mention it very briefly. It's a very complex algorithm, but what we try to do is, let me start with saying that, like OPAL is about how to analyze the data. But before the analysis part, we are working very closely with we have an external research ethics committee, we have an ethical committee of the university, and we have the legal department of the telecom operator. Mm-hmm. So and with the researchers, we're working very closely, first of all, to satisfy all the GDPR. So that's the first thing that we have to comply. And then what we work on is that, because there are different data challenges before, like there is an initiative which is called Data for Development. And then the second one was this, this is an initiative by Orange Telecom Operator, which is already patented. It's a trademark. And then we had this Data for Refugees, which was done by a different telecom operator. So both were supported by not only European Union, but also World Bank, like a lot of international organizations were involved, of course, in the ethical part. So there was already an attempt to start this ethical procedure. And in our case, what we are going to do is the first step is how to anonymize the data. And I already mentioned that we have the data based on people like calls and the users. And then we have the data on the cells. So we are trying to do is, first of all, the anonymization of the users are easier because it is done by the telecom operator. And the anonymization of the cells is a bit more difficult. So normally what we do is, because the precise longitude and latitude of the cell tower, and we are adding noise. And now our team in Utrecht are working on how to develop a noise which will be sufficient to have enough details for us, but not so detailed that those people could be tracked. So it's a kind of optimization problem that we are working on. And after the anonymization part, OPAL is a system. So normally it started as a small algorithm for the humanitarian resources. Datapop Alliance with the MIT and Stanford and Humanitarian Action, they do it. And we are trying to adapt it to our case. OPAL, you can see it like an ATM, like a bank. So you don't have access to the money, but you can do a lot of operations on the ATM. At the end, you can get what you need. Either you can do a transfer, but you don't know what's going on there, and you do not see the other person's account, so you don't know what's going on. You only know what you do. And this algorithm will allow us to be able to run some queries, but not every query. All the queries will be authorized by the ethics team, research team, and the legal department. So they will know what the aim of the query is and what we are going to have at the end. So the first part is anonymization data. The second part is how you can run an analysis on the data without having a real access to it. So we are building a server in the telecom operator. And now, like we are not going to go to Istanbul, so everything will be done online, but like it will be like the queries and we will have the outputs and aggregate outputs. And I think what is crucial that I forgot to say is that we are not working with the full set of the users. We are working with only 1 million users. So in Turkey, Turkcell has already more than 30 million subscribers. And we will be working on one representative sample of 1 million. I don't know if it answers the question.
Okay, so it's all based on close cooperation with the operator.
Yes, definitely.
Mm-hmm.
Definitely.
Okay, thank you.
And we are trying to find a kind of, not to find, but develop a framework for that, that's why we are, let's say, documenting every step. So for any future, like collaborations, it can be a kind of a guideline. But we are also coming with a lot of issues, like for instance, in the recent one that I mentioned about the seasonal migration, the legal department said that for the, like with the longitude and latitude, you have a number and then the decimals going forever. And then they said, yeah, we can give you up to 20 kilometers, but then the 20 kilometers radius is a very large like it could be 2 towns, like in a small country. So now it's negotiating. So it's really try and fail and try again. But we are paying, for me, like for our consciousness as a social scientist, we are very careful of, like protecting the rights of everyone, especially such a vulnerable group.
Thank you.
Thank you very much, Tuba, for answering this question. There is another question to you from Matthew Scott. Matthew, if you could go ahead.
Yep. Hopefully everyone can hear me. So the question was originally said specifically to Tuba, but I think I can frame it more broadly and bring Carlos in as well, because it really relates to the question about the potential adverse implications of using big data in ways that start out with humanitarian objective or even human rights priorities, but could be used in different ways. So the first point that made me think about this was the idea of the night lights and being able to zoom in on undocumented people living in Turkey, and for the purpose of understanding the conditions there or whatever other humanitarian purposes. But how do you avoid, in that context, that data being used to detect, detain, deport such people? So that's one example. And in Carlos' example, using the modeling of predictive attitudes, couldn't that be used in negative ways as well, or ways that are less aligned with human rights? For example, here we detect anti-migrant attitudes. Great, we want to challenge that. What happens in an authoritarian regime that wants to detect parts of a city that are anti-government or something like that? How do you avoid your use of big data and technologies having adverse human rights implications? Thanks.
Tuba, Carlos, go ahead.
Yeah, okay. So may I start, Carlos?
Yes.
Okay, so I mean, very, very righteous question, and it is very difficult to answer. I can, of course, talk on our behalf, but I will start with a broader example, because this tracking issue has been discussed since 2015, where IOM worked with the satellite images to detect where the refugees, like fleeing, or to reach to, like to make this humanitarian help more accessible for them. So they knew where they are. So the planes go there. So, and then it was a huge success, but then it brought a lot of questions about, is it only about privacy? Okay, so I discussed a lot about ethics, but I removed a slide from my presentation, which was about the political aspect of use of big data, because now we are not, I mean, based on your question, we are not talking about only this human, because when you say rights, we are talking about the policy, politics, power. So who has the data, who has access to data, how to manipulate the data. And in our case, what we try to do is, of course, we count on the good intentions of the, like local governments, because, like their aim to help is to help those people. And like one of our partners, Chilled, they are in Italy. They are mostly like lawyers, and they provide legal assistance. And they're very skeptical about this use of big data, because you can detect the boats on the sea and you can stop them coming. So we have some opponents, I would say, or some critical opinions. We have people with critical perspective on big data on board, because I think we need that. So it's a kind of auto control system. And in the specific example you asked, we are working with the 2.5 kilometers radius. So it's not like the block or the building. So we say that, okay, in this area, for instance, we do know that in the specific cases of Istanbul, there are some industrial areas where they have, let's say, textile sector, and they work a lot with daily, labor. And then we could see that, okay, so normally this is not a residential area, but there are people who are living there. So which could be also observed through, I don't know, daily watchers or police or whatever. So especially, for instance, in our case, municipality is very much interested in how to help child labor, because they would like to see, there are a lot of unaccompanied minors. We are talking about, kids above 12. So, but they don't have any access, so they don't know where they are. They didn't go to school, so they really want to reach out. And so it is based on a bit, good intentions relations, but we are following very closely, and we do not give anyone the data. We are developing indicators. So we say that, for instance, if there is, these workshops, if there are too many workshops around, there is no residents, but it is close to that specific area, it might be with a high probability that you have people living there. So we let them to see further. But I think it's a very fundamental question. And we also submitted another project with Carlos and other colleagues, which is not a research project, but an infrastructure where we hope to set a platform where social scientists have more word, let's put it this way, on also the governance of big data. Because now when you say governance, we're mostly talking about politics and politicians. We are talking about Europe and the world on the right wing rise. So I think we try to do things, but I can't give you a specific answer, which is very satisfying, say that we assure that, but we do our best to assure also the, let's say, the power balance or optimization of the power.
Carlos, go ahead.
Okay, thank you, Mati, for your question. And I also share your concerns, and I think most of us share your concerns. And what Tuba said is right, just right. It's difficult to answer. I mean, since the appearance of technology, and if you go back to nuclear studies, we can do good things in physics with atomic studies, but also we can build an atomic bomb. And the same with the machine learning, with big data, we can use it to classify images to predict lung cancer, for example. But we can use it to things that are not ethical or that are not good. So there is a big area in big data study which is called big data for good. In order to avoid many of the concerns that most of the people have about how we can use these algorithms and this data to spy people or to get benefits from them when they don't know that we are doing. And actually, if we will go back to this to some of the scandals in the United States that also was in Germany, for example, in the United States, the Snowden scandal using large data of telephone records in order to predict attitudes and behaviors of people, we know we can realize how bad it could be, the wrong use of these technologies in surviving people or for spying people. So I right now am conducting a national survey in Spain in order to detect what people think about machine learning, about big data, and about artificial intelligence. And I'm very surprised that even when we have a lot of benefits, like some of the ones that we're showing here, it is true that people think that most of the results might be bad for their own life. So they think that these kind of technologies are coming to take out or work for, or jobs. For example, artificial intelligence is going to produce no more jobs in the society, or machine learning or big data is going to be used to spy. So it is just for me a matter of ethics. And your question says, okay, we can use this model or this machine learning model to predict, for example, negative attitudes towards or refer to anti-governmental or anti-government issues. Of course we can use it, and I cannot say that they are not being used right now. But even if they are being used wrongly from my perspective, I think we have to fight to use these technologies and to use this infrastructure that the one Tuba was mentioning for migration study, use this infrastructure to build things that solve problems, and good problems that are real, that are beneficial for society. But the uses that are going to be the uses that can be that we can apply some this implementation for bad things, I mean, it's out of our reach. I mean, it is an ethical thing, as well as the biases in the algorithm. I mean, we as a practitioners, we want to just, I mean, it's like in traditional social study, when you use statistics, you can use statistics for good or for bad, for saying the truth or for lying. So we are using this from an ethical perspective for a good reason, and this is why we bring it into migration studies. And I think it can be very, very beneficial for migration studies if we keep on working on that.
Could you, thank you very much, Carlos, for this. Could you say a little bit more about the findings of your research? I found it fascinating when you were describing the method as such, but I felt a little bit, I wanted to know more about the results, and especially how do you explain the results? So this is the question about what cities, locations, were found to be most hateful to refugees, migrants in your research, and how to explain that?
Yes, I have two parts, and we have more advanced results in the case of the survey extrapolation, which I show you on the slides. We don't have yet the final results for the hate speech detection at the regional level, because so far we built the classifier, which is probably the most difficult part, because it's very technical and needs a lot of validation. So we are going to conduct to implement this classifier in all regions of Europe next year. I mean, during 2021, we're to detect that that cities that produce more or less hate, but we don't have it yet. So we cannot, I don't have a result to say this is a not hateful city, but I do have a result that I can tell you which city or region have more negative attitudes toward migrants or refugees. So what we're going to do next year is to complement these two big data approaches in order to see if they are similar. I mean, if where there are worse attitudes, there are a lot of hate speech or not. Our hypothesis is they will be similar, but that is what we want to test next year when we implement this detector that we developed this year.
And to what extent, following this, to what extent the location of a, let's say, an NGO or a foundation or a think tank that is famous for example, spreading hate towards various types of groups, the location of this type of let's say, institution in a given location will influence the findings of your research. I'm just thinking in terms of Poland. There are certain institutions which are famous for being the key sort of loudspeakers for hate speech, and they are broadcasting from certain locations. I wonder to what extent their broadcast, which is so visible on Twitter, Facebook, whatever, social media, to what extent this would affect the actual findings of the research and what the larger population thinks as such in a given location.
Yes. First of all, I think the goal for this approach is not to estimate the thinking of the whole population. So we are aware that we can. This is not representative. So we want to see the feelings in the social network for persons that already have an account there and produce information, but also from institutions or organizations, or even bots, or automatic replication of hate speech that we know that exist, and they transmit fake news and a lot of hateful comments. So we are looking for that sources, and to see probably the impact of that sources, even when we are aware that those sources are not, they do not represent the thinking of the whole population. But what we do know is that this organization, that those that you mentioned, that will have an important role in the diffusion and propagation of hate speech, where we find this organization and where we find these movements of hate speech production, we will find a problem. I mean, the fact that we know that in some countries, some locations, we have this organization producing hate speech, it will reveal us that probably in that place, there might be real problems in the next time, because this hate speech produced by this organization will affect the context. So it doesn't mean that the organization reflects on the whole population thinking, but it means that the production of the organization will affect the thinking in the future, in the near future, of the not only the thinking, the behavior of the people, because we part from the hypothesis that the more hate speech produced, the more hate crimes, hateful attitudes behaviors we will have in the future. So by detecting these, we will predict not only a picture, a cross-sectional picture, but we detect in the future how the attitudes will be, on how the behaviors will be. So that is important note that you do about the organization, and we will actually, when we do this work, we will also focus on identifying the sources, which means that besides the amount of hate speech, we will identify the specific sources that are producing most of this hate speech. So by identifying the sources, we can give more explanation to where it happened, to what is happening in a place.
Fantastic, thank you very much. We are going slowly towards the end, but I wanted to also ask Tuba and you, Carlos, a general probably question: what do you find in your work? What were the biggest challenges so far in your work that you encountered while working with? Here I asked Facebook data, but I would say more generally social media data. Like one of the issues I found is that, for example, this data on stock of migrants is interesting and it gives me some information, but sometimes I found it super difficult to understand, for example, why in the marketing tool I'm able to figure out the number of citizens of India that live outside of the country, and I'm not able to find the same characteristic for any given other nationality. So this is one of the things that drives me crazy while working with this type of Facebook data on stock, which is kind of why is it not replicable to other nationalities? Why these categories are such as, and why they don't have the for example, diaspora sort of category all over the. So these are my issues. I was wondering, what are your experiences and what you found as a most sort of difficult element of that?
Yeah, difficult questions. But before that, I saw that one of the, someone from the audience mentioned the book Everybody Lies. I think it's a great read, and I will even suggest two more. One of them is probably you already heard, Reinventing Capitalism in the Age of Big Data, which is a great book as well. But my favorite is Invisible Women. If you haven't heard of it, you should definitely read it. It's a amazing book. So why I mentioned those books is also regards to your question, because I think we have a lot of challenges. And I think we should also acknowledge that we cannot solve all of the challenges, but we need to find a way, first, how to be aware of what's going on wrong or what is not there, and be very careful with the interpretations. On the example you talked about the Facebook, I mean, I'm working with the Facebook data, not with the API. I'm also working with the Facebook groups. You know, like I use Facebook groups a lot to recruit, like respondents, because I'm also working qualitatively, and we are trying to reach out to very specific groups. For instance, I'm working with female, highly skilled family migrants. So you cannot see them in the sampling frames. I don't see them in the statistics, so it's very difficult. And yeah, with Snowball it works, but I want to reach out to other nationalities, as you say. So I really use this. I'm not a social media user, an active one, but I have an account, so I use it. Or I know that, you know, colleagues from HESIS, like Stefan Butcher, they are using Facebook to recruit respondents for surveys. So they're trying to develop, let's say, they are looking for Polish workers in the UK. So they tested Facebook ads, you know, like if they can reach out to more accurate targeted groups. So in fact, Facebook data is not limited to API, but a lot of people use it because it's the easiest. Like one option and one thing that we try to do is with especially the Syrian refugees in Belgium, we are in touch with a lot of group administrators because we wanted to analyze what they discuss. We are not interested in who they are, where they live. We know that they're in Belgium, they clear, and they say that they are Syrian refugees, but we wanted to understand which question they ask, you know, what information they need, how they solve their issues. But we had a lot of problems with the GDPR because unless the group is public, you cannot web scrape the information, what they discuss. But, you know, like we found a couple of cases in some small groups, all the members approved, so we could get some content. So there are different ways, but with the API, I think it is based to the selectivity bias, because Facebook is not the most favorite social network everywhere. Like in the Turkish case, the users are, you will be surprised, mid-age or older housewives. So a lot of people assume that social media is used a lot by the youngsters, but there might be some specific case which is not. So I think it is very important to understand the demographics of the users in different contexts. And in some countries, it is pretty normal to say where you live and fill in all the about information, whom you're married to, when you graduated. But in some countries, people are more, let's say, conservative about their information, so they don't put it there. And it is not a systematic thing that you can easily detect. So I think Facebook is working way better for some, let's say, mid or high educated people with lots of digital literacy. So, but what information you will find is a different one. So for me, in general, with the big data, the main challenge is the working with the data scientists. Because, you know, the machine learning and by the way, I'm a statistician myself. I don't have anything with the programming or the numbers, but I think it is very difficult to set the lines between the theory-driven research and data-driven research. So seeing a pattern doesn't mean that, you know, like you can explain what's going on in that community. So I think we have to be very careful, and we have to collaborate more in general with each other, between different disciplines. Even between psychologists, sociologists, and political scientists, we talk about the same thing with different jargons, with different terminologies. And when you read a paper, especially from a data scientist or computer scientist on big data, you'll see that they refer to mobility as migration. And then, you know, like when they say socio-economic demographics, you know, they are only talking about age and gender. So, you know, like this I have to say, overgeneralization is there, but I think it doesn't mean that they are doing it wrong. We can do it better. I think together it could be better. So, and the ethical aspect, my final remark will be this, the ethics and the privacy. I think we have to think a bit bigger than that and include this political aspect in there as well, because big data is privately owned. So we do have governments who regulate the companies. So for instance, for the Hummingbird, we are working with more than four companies, and some of them says, like if the government, there is an American one, is that if the government asks us to give the data, we will, because it is their regulator. So they don't think from that other perspective, but then they don't provide the data to researchers because the consent is based on the use of data by the company, not by the researchers. So I think we still have a long way to go and study this power, politics, and policy aspect of this ethical and the legal of the big data. But I do believe that there is still a lot to discover. I think there's a huge, enormous potential of the utilization of this big data, and it could only, especially for the big, migration research, it could only get better with us involved more. So we have our own reservations and questions, and I think we have to, there had been long discussions between qualitative and quantitative researchers, which one is better. Today, we are talking about mixed methods more, like how to complement each other. And I think big data will be just part of the quantitative part, but they also have a lot to learn from the qualitative research, especially if you're going to talk about attitudes, like the integration. So it has a lot of potential for the collaboration. So I think that's the big profit.
Thank you very much, Tuba. Carlos.
Well, actually, I also agree with Tuba with everything she said, and it's a difficult question. There might be many challenges in the use of big data. Tuba mentioned many of them, so I won't repeat, but I agree with those. Probably I would add one, which is one challenge that I normally explain the students that when I teach big data. An undergrad or graduate course, I normally say that big data is messy, is noisy, and is not clean. So when we're working with big data and we are going to apply it to migration studies or whichever field we want, the first thing we have to be aware of is that big data is complex, it's useful, but it's not like the data we are used to in a content analysis, in an experiment, or in a survey, that the data is clean and has been really processed, that we can work more comfortable with that data. Big data is not only, it has a lot of biases, it is not representative, but also when you get the big data, the social media data, or databases at the scale that you have to join different, for example, databases to create a new one, normally the first barrier that you find is that it's very, very difficult to work with because it's messy, it is not clean, and is in disorder. So this produces a low quality of result if you don't work properly with this data. So normally there is now a trend to say that big data goes small data. This means that we have to apply many methods in order to convert that big data, a big amount of records of messages, in order to have something more, something that you can deal with, and you probably can apply traditional statistic concepts. Just for example, as you are in the field of migration study, you use a lot of statistical inference. Like you're familiar probably with the p-value in statistics, and when you're working with statistic at big data at the scale, the p-value doesn't have any sense because the sample size is so huge that we cannot apply any inference. So the inference that we use in traditional statistics, even the Bayesian inference, have very hard problems to solve in big data. So the connection between this messy big data and good traditional methods applied in small data is a challenge that we still have to cover, have to work in order to have better predictions, better models, better results, and of course, better explainability of the models we are building. So probably for me is the challenge that that we still face in working with big data and the application of this big data approach in the field of migration studies.
Thank you very much, Carlos. Thank you very much, Tuba, also for the recommendations that you've given to books. Dobruja has posted the links to the books that were mentioned, recommended, and I understand our distinguished speakers also give us the permission to send to put together with the actual video of this seminar the presentations on the website of the observatory. So within the next days we should be able to also distribute this seminar and this data in such a way. And I hope it is a first encounter, but not the last. So once again, big thanks huge thanks for your time today and for fantastic presentations. I still have many questions unanswered, but let's leave them for the next meeting. So once again, to all participants, there have been over almost 60 people that join us today. So big thanks, and see you probably next month, the next MMO seminar. So once again, thank you very much.
Thanks a lot. Have a nice day.
Bye.
Thank you.
Thank you.